take a look at our 13th example. And we got 4x minus 1 over 5x equals x to the fifth minus y to the fourth. There's different ways you can solve this one. My first idea when I saw this problem was to multiply everything by 5x to get rid of the fraction, mainly because I didn't want to do the quotient rule. And that would work. You could also do the quotient rule on this side. That would work. But another way you can do is whenever you have a single item in your denominator, in this case a single term, then you can split them into separate fractions. So I can put 4x over 5x minus 1 over 5x. Now again, these are just to give you examples. You're not going to have one on test necessarily that has a single term down here. So don't count on that. These x's cancel, gives you 4/5 minus 1/5, and I'll take that x the first up on top and becomes x to the negative 1 equals x to the fifth minus y to the fourth. Now implicit differentiation, we'll take derivative of everything where it's sitting. So we'll take derivative of 4/5. We'll take the derivative of negative 1/5 x to the negative 1. We'll take the derivative of x to the fifth. And we'll take the derivative of negative y to the fourth. Well, the derivative of 4/5 is 0. That drops away. On this one, the negative 1/5 stays out in front. Take your power, put it out in front, lower it by 1. X to the fifth becomes 5x to the fourth. The derivative of negative y to the fourth is negative 4y to the third, and then we'll add on a y prime. Because we're taking derivative with respect to x, and whenever you have a different variable, you take derivative just like normal, but you have to account for that variable then. And we do that by adding on a y prime. Okay, negative 1/5 times negative 1 gives us positive 1/5. And actually add x to negative 2, I can go ahead and take downstairs here. So we get 1 over 5x squared equals 5x to the fourth minus 4y to the third y prime. Now we want to solve for y prime. And always whenever we're solving anything, one of our first steps is to get rid of fractions. And it's always the same steps. You multiply everything by the LCM of all your denominators. We only have one denominator, the 5x squared, so we'll multiply everything by that. So I'll multiply the 1 over 5x squared by it. We'll multiply the 5x to the fourth by it. And we'll multiply the negative 4y to the third y prime by it. Now over on this side, that gives us 1. 5 times 5 is 25. X squared times x to the fourth. You add the exponents when you got x to a power times x to a power. So we get x to 6. 5 times negative 4 is negative 20. X squared, y to the third, y prime. Now I want to get everything with y prime on one side, so I'll take this negative 20x squared, y to the third, y prime to the left side. And I'll take this 1 to the right side. So we're going to get 20x squared, y to the third, y prime is equal to 25x to the 6 minus 1. Now we want to get y prime by itself, so we're going to divide both sides by what's in front of our y prime. So we'll divide both sides by 20x squared, y to the third. When we do that, these 20's cancel, these x squareds cancel, these y to the thirds cancel, and we're left with y prime is equal to 25x to the 6 minus 1 over 20x squared, y to the third. And that's our answer.